Moving from the sprocket then takes us to the rear idler wheels. The idler wheel components are again strewn out here on the table. They consist of a few separate pieces. We have here the front of the idler, the rear of the idler, the hubcap, the retention plate, and ball bearings. Now, the idler designs, just like with the sprocket, have not changed from the other iterations of the Armortek King Tiger release. The idlers themselves are exquisitely made and are very nicely done. Starting with the face, you can see here it has all of the detailing present for the face detailing of the King Tiger rear idler wheel, and also has the correct shape and depth to it that we have on the surface. All the holes for the hubcap are pre-drilled and tapped, and all the recesses are appropriately machined. Same can also be said for the inner recess of the wheel itself. Now, the two pieces, just like with many other King Tiger kits on the market, are simply connected together like this, and on this model here, they're actually meant to be glued, or was requested in the instructions to be epoxied into place. Rather than utilizing just epoxies alone, I'm going to go ahead and drill 2 holes into this back section here and tap and thread, so I can put 2 fasteners that secure and hold the sprocket, or the rear idler wheel, I should say, in one solid piece. This is one modification I'm going to make to the rear idler. Other than that, there's really nothing more that needs to be made. These pieces here can literally be assembled out of the box, as they are exquisitely made, and there's not really a whole lot of room for improvement, which is a plus. As for the ball bearings, again, this is usual as per Armortek, and keeps the idler wheel nice and centered on the spindle, and gives it a very nice roll to it with very little friction. Moving to the retention system, this is standard Armortek with that of steel CNC disc with the use of countersunk fasteners. Once secured in place, prevents the wheel from loosening and falling off the center axle. And then, as for the hubcap, it's just a CNC'd aluminum disc with some holes in it, and the holes, of course, line up correctly with the ones found on the rear idler itself. And here we have the modified idlers compared to the stock units. Like we saw before, the stock units are meant to be epoxied together and are then held in place once mounted to the tank. Rather than using that method alone, I went ahead and modified the units, and that's found in these 2 examples over here. The way this is done is again with that of fasteners, and I went ahead and carefully marked and drilled out these 2 locations. And on the rear, or on this portion here, you'll see that the pieces are actually tapped and threaded into the material. Now, because this is comprised of a single solid piece of CNC aluminum, there's a lot of metal and material here in order to do this modification. But you still have to be careful of your parameters, as you don't want to have these holes slip and emerge outward into this area over here, as these areas here are required for the 2 pieces to click together. Same thing can also be said to the rear portion of the idler wheel. On the opposite side, I have 2 larger holes that are bored into the material, and these are to act as countersinks so that once the cap screws are added, they are flush or beneath the surface of the wheel, which of course will prevent anything from snagging up and will also cause any alignment issues. Just like with the recess area, you have to watch out on this section here not to have anything fall into this cavity over here, as this cavity is absolutely important due to the ball bearings that need to be added. With these 2 out of the way, I'm going to go ahead and make the revisions now to the last 2 idler wheels. And here are the idler mounting equipment ready for installation to the model. Now, many of the components that you see here were already previously covered in more detail in the previous scene. However, I want to focus my attention to the equipment in this section over here, as these are very important and were not fully talked about the last time I was mentioning these components. Starting with these 2 CNC'd brass tubes, these here are the actual bushings that the idler mount gets to pivot along on the inside of. These bushings here also insulate the steel idler mount from that of the aluminum idler mount base, which was mounted to the lower hull and is mentioned in a previous video. Moving from the bushings takes us to the cam pin. This equipment here would get mounted inside of the swinging link, and by tightening or loosening a very long fastener, this will allow the piece to pivot either in a tight or loose manner, which will be determined by the user of the tank once the track is on, and for again use for setting track tension. This component here is that of a housing for that of the fastener head. It will slide into here, and if you notice, it's drilled out all the way through, so you can go in here with an Allen wrench and tighten and loosen the fastener once everything is assembled. Now, one very nice trait that the Armortek King Tiger has is that of these two laser cut steel plates. What these steel plates do is they secure the fastener to the rear portion of the tank. Once the vehicle and the pieces are mounted on the inside, you'll get to see it in more detail. However, basically what they do is they prevent the fastener from backing out if track tension is ever lost. This is something that is seen on the Armortek King Tigers, however is not seen on other vehicles such as the Tiger I, and even their more older generations of Panthers did not have this plate present. This is definitely something that is strongly recommended to do on anyone that is building a Armortek kit that does not have these parts. When it comes to time to the actual idler mount installation, like everything, it has to be done in layers. The first layer is that of the bushing. To install the bushing, it simply gets slid into place with some super glue that's going to be added on the sides just to act as a insurance policy, just to prevent it from backing out. Now, one thing to point out is that the tolerances are very, very tight on these two components here, which is a good thing. You don't want to have this to be overtly loose, as this will wobble around and can cause problems. With the pieces being the tolerances as they will be nice and tight, and once installed, you're not going to have to worry about it backing out. Even though I am still going to add a little bit of super glue to this little portion here. Now, the instructions recommends using Loctite for this application. Both materials can be used intermittently, in my opinion, as I've used both in the past. When it comes time for mounting on the idler mount, I simply line it up. And in this case, it slid into place. The one on the opposite side did require a little bit of coercion with that of a rubber mallet. However, once the piece is installed, wipe away any extra adhesives that are left, and I'm now ready for the next step. The next step is to mount on the actual idler shaft. Now, if we notice, I peeled off the masking tape that was on this section here, and what I'm going to do now is I'm going to add a smear of grease to these locations, as you do want it to pivot and you do want to protect the metal from any sort of corrosion. So with a little smear on my finger, I'm going to go ahead and apply the grease. Now, you don't want to have too much grease, just a little nice little smooth layer where it's evenly coated is more than suffice at the task at hand. Wipe off my finger. And now this guy can be slid into place. If we notice, the tolerances on the bushing and the idler mount are absolutely perfect, and no modifications need to be made to these whatsoever. Once the idler mount is in place, the next thing I'm going to do is add the fastener head cup to its milled-in recess. For this, again, a few drops of CA around the circumference of the part is more than suffice for the task at hand. Once the CA is added, it just gets pressed into place. To make sure it's fully in, a few taps of rubber mallet, just to make sure that the piece is fully seated. The next step is to add the pivoting yoke to the rear section here of the idler mount. Now, on this build here, I noticed that the tolerances of these two pieces are very, very, very tight. So much so that you can't possibly coerce it in with a rubber mallet, but in my opinion, that's just a little problematic. I'm going to instead, with a Dremel, with a high-speed cutter, I'm going to go ahead and remove the material around this section here. Now again, this has to be done very carefully, as you want to keep a nice, precise, square hole so that the piece doesn't wobble on you when it comes time for the installation. And you also don't want to remove too much material, as then it'll become too loose and the piece is basically ruined. Just a little bit of material is all that needs to be removed off this part here. Now, since this is a aluminum alloy type metal, this cutter blade does do some very quick work with the removal. Now, rather than using this bit here, another bit to use is that of a Dremel with a sanding drum, and that will also yield the exact same result for this application. And here's the pivoting link with the material removed. Like I said before, it's just a minor amount of material that needs to be removed, just so that the pivoting link can fit smoothly over the axle, like so. Now, if we notice here that there is a hole pre-drilled into this link, as well as a matching hole drilled into the shaft. This is for that of a single fastener, which will be bolted directly through and hold everything firmly in place. It's a very simple design, but it's also very efficient. The holes line up absolutely perfectly, and now it's time to simply install the fastener. Now, even though the hole is not threaded, with the tolerances of the two parts, they kind of lock into each other. That makes them so tight that to get the fastener in all the way, you can simply just thread them in as you would if it was a nut. Now, you can try drilling it out with a drill or even trying to coerce it in with a hammer. However, that's really unnecessary, as just by screwing it in like the way I have here with a standard Allen wrench is more than enough to do the job. Now, at the very end, the threads will protrude, to which then you could mount on that of the actual nut. Now, of course, red Loctite is definitely recommended for this. And a quick little drop on the piece. I simply start the threads right here and just finish off with that of the wrench. Just thread it in until the fastener bottoms out, and everything will be in a nice, tight, installed manner. Just to prevent the piece from slipping a little bit, I'm just going to grab it with a plier. Torque that down. Once everything is tightened, the yoke is now mounted permanently to that of the idler shaft. It is at this point here where the shaft can no longer be removed from the tank, and you're now ready to install the adjustment components. Now it's time to add the pivoting cam. Just before the installation, I put a little smear of grease on one side and another smear of grease on the inside hole here of the pivoting link. Purpose for this has to do just for basic lubrication, as this does need to swing and pivot. The holes line up and they just get tapped directly into place. Once the brass camming pin is added, it's then time to mount on the adjustment fastener. Now, like I said before, the King Tiger is unique in that the locking fastener has a retention plate that prevents the fastener from popping out when the tank's track tension is lost, say for a derailment or possibly even something like a track link actually snapping. Normally on these tanks, this is basically the setup that you have. With the way the idler system is designed, once you have the track on the idler, the track will want to pull in the wheel in this motion. With the way everything is designed, when the track is pulling this way, it's putting force towards the back of the tank, which keeps the fastener butt up against the retention cup and keeps everything firmly in place. The problem comes when, if there's a loss of track tension for whatever reason, this could easily happen. If this happens, the fastener head is no longer in the cup. Now, I've mentioned this a lot in other Armortek build videos, like for the Tiger 1, as if this happens, you are in a world of hurt, and you're going to have to basically take the tank apart or get access to the engine compartment and fish around to get this guy back into its proper location. At Definitely not something that you want to frequently do. Now, normally on my builds, I design and fabricate a plate that goes over this section here that prevents this from ever losing. So if track tension is ever lost, the piece will never just simply fall out in this type of a manner. Now, on the Armortek King Tiger, this is not a issue or something that needs to be done, as they supply you with this exact same part. And what's interesting is that the part actually mounts on the exact same manner that I do it on the Tiger 1s. Only on the Tiger 1s I have to modify the rear plate in order to have the fasteners set a certain way. That's not going to be the case with the Armortek, as it comes like this out of the box, which is a great lifesaver. As for the installation, you first put the fastener through the plate. You then thread the fastener onto the idler mount. You want to get the fastener to a certain point so you could pivot it into its location, and the plate can also slide in too. Keep in mind, with this version of the Tiger, of the King Tiger, you have this block over here for that where the plates are all mounted together, and you're going to have to slide the plate into place in order to get it seated in. It's not very difficult to do, but it is something you have to keep aware of. Once the fastener is ready to go, the piece just clips directly into place. As at this point here, I can now mount on the fasteners. With the bolts added, the idler mount system is completed. As you can see, the plate does a fantastic job in keeping the idler mount system in place, and you're not going to have to ever worry about it popping off on you if track tension is ever lost. Now, as at this point here, I can go ahead and mount on the actual idler wheels themselves. To install the idler wheel, this is a pretty straightforward process. First thing I'm going to do is I'm going to peel off the protective tape that was used again for masking during the painting process. With the tape removed, it's then time to add the smear of grease. Just like, this is the exact same procedure that I do on all these builds, as well as also on the rest of the road wheels as well. With the grease added, it's then time to mount on the ball bearings. Sometimes a little tap is all that's required. Get them fully seated. With the ball bearings on, the wheel simply slides onto the axle. Once the wheel is slid onto the axle, it's then time to mount it on with that of its retention plate. Here is the retention plate that has been primed, by the way. Slip it over the fastener. We're going to add a small drop of Loctite to the threads. Also make sure there's no grease or lubricant on the location where there's threads, as that will cause an inhibitance. And I simply just thread away. Now I like to bottom it out, and then once the wheel's bottomed out, you're going to, or once the fastener's bottomed out, you can see that the wheel is going to have a little bit of resistance. So what I do is, after I bottom it out, I carefully back out, slight amount, until the wheel gets loose enough so that it spins perfectly freely, but not too free that the threads can outdo themselves, and then the piece can fall off. And there we have it. Now once the retention cap is added and the wheel is at a tightness where it spins nice and freely, it's then time to add on the Detail Hubcap. This is just added on with several fasteners, and it's basically built out of the box, as the kit one is nicely done. I'll start it and just tighten away. And if you notice, one little trick that I do is that I put the tool onto the wheel and I just simply spin it in a way which tightens the fastener, and it's a speedy way of getting these fasteners on in a pretty quick manner. I'll just finish them off by hand. After the last of the fasteners are added, the idler wheel is now complete. Moving away to the tank's hubcaps. The hubcaps found on the Tiger II really are two different versions. We have the hubcap for the inner wheel and the hubcap for the outer wheel. Now, with the way the King Tiger suspension is designed without the inner leaf and wheels, the versions for the inner wheels are going to have a longer stem to them compared to the ones found on the outer road wheels. Now, the Armortek kit supplies you with, of course, obviously both sets, which is, of course, required for that of building a King Tiger, and the pieces themselves are made out of a single turning of CNC'd aluminum. These pieces are very nicely machined, and if you notice, are threaded, as the way they secure onto the tank is you add a little bit of Loctite, and you physically thread this into the correct location, thus holding it there firmly in place. As you can see, it also has the holes for that of the fasteners, which on the real piece here, this cap is a flange, and by undoing the fasteners, you can remove this section, getting access to the bearings underneath. The center hole that you see here is actually that of a Zerk fitting in order for you to add the lubrication to keep the bearings all nice and lubricated, which of course one needs for a heavy equipment like this, as the ball bearings are subject to a lot of wear and tear. This is also true, by the way, with the Zerk fittings for all the German tanks, from the Tiger 1 all the way up to the Panther and even the Panzer IV series as well. Here you can get a good idea of the type of machining that is found on these pieces. And as you can see, of course, like I said before, are very well made. Now, to take the piece from this point here, I'm going to add some details to this piece. The details I'm going to add is that of cast texturing, as on the real King Tiger, these pieces here were actually made from casted metal. Now, in addition to that, you'll notice that the flange is undefined and that it's just a simple disc. Of course, like I said before, in the real one, you would undo these fasteners and this top portion here would pop off of the center stem. To do this, I'm going to machine on a small little crease line, which will give the illusion that this piece is actually two pieces in one. Then there's also another bit of detail I'm going to add, is that of the blisters that are found under the hold portions that we have here. Being a casting, this piece would have had these integral blisters found over each of the fastener location holes, and the reason for that is that this gives the material for the threads to grab onto the piece and for the piece to be a nice, strong metal component, as opposed to something that's thin like this, which on the real vehicle can possibly suffer crackage and breakage. These details will be added to all of these components, and once added, these pieces will definitely be improved from leaving them with the stock offering. And here are the hubcap covers in their process of being reworked. The first two mods that I made was that I first went ahead and added the little blisters for that of the fasteners, which would be on the bottom portion here of the flange. These were sculpted out of an epoxy, and then were flared in with that of the cast texturing. In addition to the cast texturing, you'll notice that I went ahead and on the lathe, I went ahead and machined the little groove on this section here. The purpose of this groove is that this gives the illusion that the two halves are two separate pieces that are bolted together via the faux fasteners, which will be added after these pieces are past this point. And the best way to add this little seam line here is with the use of the lathe. The lathe this is one of those procedures where you absolutely have to have this type of a machine. If you don't have this type of tooling, you really are not going to be able to add this little bit of detailing here. Now, before I go ahead and add the groove, I'm going to go ahead and hit the face and the side portion of the flange with some sandpaper to remove any sort of putty left over from that of the cast texturing procedure. Once the putty is sanded away, it's now time to add the groove. Now, the groove itself doesn't have to be too far cut into the aluminum. You just want a nice little indentation on the surface. Now, you want it deep enough where it shows the separation of the two parts, but you don't want it too shallow where, remember, keep in mind, it has to be able to stand up with the layers of primer and paint that are going to be added subsequently after this procedure here and as the build progresses. And here's the hubcap spindle now with its groove detailing added. The only thing I'm going to do now is to touch up these areas of cast texturing which were pressed in by that of the jaws of the lathe. After this is reblended in, this entire piece here will be ready for that of its coat of primer, base coat, and as well as installation. And it's also important to point out that I'm going to do the same procedure with the groove to the outer road wheel hubs, which do not have this longer stem portion that we have here. Now, regrettably, one bit of detailing that I'm not going to be able to mount on in this video has to do with that of the hubcaps. Like I said before, the Detail Hubcaps were modified to be more improved from the kit original. Now, if you notice, the kit detailing has these holes around the diameter here of the hub. These are for locking fasteners, which is just a detail element and serve no function. Now, to improve this, just like with the wheels where they have the retention straps, the hubcaps do have a similar feature, albeit a lot smaller compared to the road wheel counterparts. Now, I did develop a set of 3D printed drop-in fastener detailing inserts. Unfortunately, when I designed them, I made a mistake with the scaling, and these pieces are underscaled and are not going to be utilized on this piece here. Now, I did make corrections to the scale, and those are currently at the printer, and once I get them in hand, I'll be able to complete the modification detailing on these pieces and get them installed. As a side note, if anyone is wondering, the pieces I have here in my hand are not 1/6 scale, but appear to be somewhere between 1/10 and maybe even 1/8. If anyone is interested in a set like this for their 1/8 or 1/10 scale King Tiger, let me know from the email address listed below, which is info@eastcoastarmory.com. Since I don't have a use for these, if anyone does need them, let me know and I could run you off a set. Now, of course, these would be on a first come first served basis, and I only have a handful of these sets on hand, so it's a first come in first served basis. With these details and fittings now out of the way, the next step is to get the tracks fully assembled, and then I can actually take the tank for a test drive. This should happen fairly quickly, and once the tank is fully running, I could then move on to the next progression on this build. And with that, that wraps up this project update video for this 1/6 scale, radio-controlled, Armortek, German King Tiger heavy tank. If you like this video, stop by and like us on Facebook, where there are more photographs of this particular build that have been posted since project start, as well as the other smaller and larger scale builds that are posted on the ECA channel. Furthermore, don't forget to swing by eastcoastarmory.com for more 1/6 and 1/16 scale builds and detail components. Thanks for watching.